Here we go. So one thing that's valuable is to first off know the basic definition. So let me write down sine, cosine, tangent. Now sine is defined to be y over r. Cosine is x over r. Tangent is y over x. Or just sine over cosine. How about once we get to tangent, I'll just go, look, it's just sine over cosine. This is x over r. Now, when I put it up before, I didn't give you the r's. You might think, where'd those r's come from? Well, you see what happens? If r is the radius of the circle. R is the radius of the circle. Yeah, wait, how about that? How about we stop there for 1 second and say, hey, what is sine or cosine or tangent? I mean, what are they? Like if you're anything like me, and I think most, okay? So now the other three are, what's the upside down of sine?
R over 1.
Right, it's cosecant, and it's the upside down, so it's going to be r over. I'm just going to go 1 over sine. And the upside down of cosine? Secant, so that's just 1 over cosine. And the upside down of tan is cotan, which is 1 over tan. Or I'm just going to go cosine over sine. I like to give all the definitions in terms of sines and cosine. So he's just cosine over sine. So there's the basic 6, made up that way. Now, r equals 1 when you're on the unit circle. So I think 99% is a fair estimate. 99% of the time we're going to be on the unit circle. And so r will just be 1. And when r is 1, sine is just y. And cosine is just x. When your radius of your circle, that stands for the radius. That means if you're on a circle and you're at some point on a circle, you're cruising around a circle and you stop at some point, you have an x coordinate, right? How far over, how far up, your x, your y. Your x is cosine of that angle you're at. It's cosine of that angle, and the y is sine of the angle. By definition, they made it that way. They said, hey, what we could do is we could have a dot on a circle, and as it goes around, whatever angle it's at, we could call the x-coordinate cosine and the y-coordinate sine, and then we'd have something that's going up and down, up and down, up and down, and we could use it when we have things like that in engines and electricity out of the wall and all kinds of other things. That's simply it. That's how this all came about. They just decided if we just track a dot, just a simple dot going around a circle, we'll see how high it is. Its y-coordinate is sine of the angle you're at, and its x-coordinate, how far over it is, we'll call that cosine of the angle. And all the other trig functions come from cosines and sines, don't they? Right? Tangent is just sine over cosine, and all the rest are flip, flip, flip. So that's it. That's trig. They just made it up that way. Usually the radius is 1, and almost always when you're on the unit circle, the radius is 1. And so then this is just y. All right, so let's get down to business then. So what do we do with the secant of 14 pi? 14 pi is more than all the way around, isn't it? Do you remember a little bit from trig? This is 0 degrees. Let's do degrees first, then we'll do some radians, huh? This is 0 degrees, this is 90 degrees, this is 180, and 270. Remember how degrees go? 90 for every quarter. Okay, now let's do radians. So, where's pi radians?
180.
Yeah, pi is right here at 180.
It's 2 pi over 2.
Right, and all the way around is 2 pi. It's back to 360, huh? That good? Yeah, so all the way around is 2 pi. Now, angles in degrees and radians are two different systems, again, for measuring an angle, an opening. So what is an angle? An angle is an opening between two straight lines, isn't it?
Yes.
So like you open a door, a certain angle, right? Now, there's two ways to measure those angles. There's the degree system, and they just made up the degree system, totally made it up. What's all the way around in degrees? 360. Why? Why didn't they make it something nicer? Like, why didn't they make all the way around a nice clean 100? Wouldn't that have been easier? Then halfway would be 50, quarter would be 25. We do like money. A quarter, 25 cents, 25 degrees. That would have been nice. Why didn't they do it that way? Why did they do 360? Did they just make it up, or did it have to be 360? They made it up.
A long time ago.
A long time ago. So think for a minute. What do we know? Think about why they made it 360. What do we know? Goes all the way around about 360. Now we know better, 365.
The Earth, right?
It's our rotation around the sun. Yeah. Back when they first were doing angles, they were using them on the seas for navigating ships. Now we just do lasers and all the other stuff. But back then they would look at the stars. They would judge their angle to know where they're headed out in the oceans. They would use angles, were first used for navigating ships. Back then, their best estimate of how long we were rotating around the sun was 360 days. That was the best estimate. Now we know a little closer. So that's it. They just made that. My point is they just made that up. They said, hey, all the way around, it must be 360. So they just made that up. They could have made it a nice even 100. The numbers would have been easier. So they just made up the degree system. All the way around is 360. That way halfway around is 180. Quarters 90. This is 270. Okay. What about the radian system? How'd they make up the radian system? All the way around the radian is 2 pi. What could that be? What? All the way around. What formula do you know has a 2 pi in it? All the way around.
The circumference of the circle.
Circumference. Yeah, let's talk about the area for it. First off, what's the area of a circle? Remember the formula for the area of a circle?
2
Pi r squared is area. What's the circumference of the circle? How far around the outer edge?
2 pi.
2 pi r. It's the same 3 pieces. You just put the 2 in the front. Do you remember that formula? So if r is 1, so if you're on the unit circle, and you make R1 on the unit circle, then the circumference will be 2 pi. All the way around a unit circle will be 2 pi. That's where they came up with that. All the way around a unit circle is 2 pi. That means that's the arc length of a unit circle. That's what the radian system is. So if you say, well, look, I'm at some angle theta, and from there to there, it's, I don't know, pi over 4. What does that mean?
45 degrees.
That means, pi. What is pi over 4? Pi is a number.
Yeah.
What's pi?
3.1.
3.14.
96.
On and on and on. Did you know a few more? Over 4. So, yeah, so pi is a number. That's about 3/4. 3/4 what? Like my old physics teacher would say. If you give an answer like 3/4, he'd say, 3/4 what, Heron? 3/4 dogs? Is that dogs, Heron? Is that how many dogs in the kennel? What is that 3/4? That's what he would always say. That was his line. So 3/4 what? Well, it turns out radians are unitless. I don't know if you know about that. So I'd say to my physics teacher, now you know, Mr. Grimes, that the radians are unitless. There's nothing. There's no dogs. There's no nothing there. So it's unitless, but meaning if you were on the unit circle, if you were on the radius 1 circle, that would be how long this arc is in whatever unit. So if this was 1 foot, if you're on a 1 foot radius circle, then this would be 3.14 over 4 feet long that arc would be. That's how long this curved arc would be. So that's what radians are. They're how far the arc is on a unit circle. But we don't put units, we don't put feet or inches or miles. We just say one what? One whatever, no units. So then these are not units either. But anyway, I'm probably going on too long. But I want you to know radians are arc length on a unit circle. That's how they made that system up. They just said, hey, let's just do arc length. That'll be the angle. So that's what they are. All right, enough said. Just want to, you've had trig twice now. I want you to know the foundations. Okay, so with that in mind, let's go back to the question. 14 pi. So 14 pi, what is 14 pi? If all the way around once is 2 pi.
7.
Yeah, that's 7 times all the way around, isn't it? So secant of 14 pi is all the way. So if I say, hey, I'm pointing at the front of the class, the board there, and I'm going to spin all the way around 7 times. Once, twice, etc. 7 times. Where am I going to be pointing when I'm done? Well, the same spot. Yeah. So if where do we start? We start right here. That's 0 degrees, right? That's where we always start. They just made it that way. They could have made the starting straight up. They just said, we'll make it the positive x-axis. That's where you start. And if you go all the way around once, twice, 3 times, etc., 7 times, you're going to end up right where you started, huh? So this is really just going to be the same thing as the secant of 0. 0 degrees. Or 0 radians. 0 in either system. Right? You guys see what I'm talking about? Because that's what we always do on these problems is we find out where does the dot end up on the circle. And then we go find the sine, cosine, tangent, whatever we need from there. So you start at 0. You always start at 0. If you go all the way around 7 times, you're going to end up at 0. So we want the secant of that spot. We end up where we started, 0 degrees, 0 radians, right there. So what's the secant? Right over here. Secant is 1 over cosine. So to do that, I've got to know the coordinates of that point. This dot right here, how far, from the origin, this is 0, 0, the origin. How far over, how far up is that dot? Over 1, up 0. You with me? That's the dot, unit circle. So this radius is 1 here. Over 1, up 0. Remember, they defined it backwards. They put cosine first, then sine. They could have done it the other way. This is just what they decided to do. So at any dot, so our job in finding all these trig functions will be to find where we're at on the circle. The x-coordinate is cosine, the y-coordinate is sine, by definition. They made it that way, and then you can find any trig function from that information. What do we want? Secant, which is 1 over cosine of 0. And what's the cosine of 0? 1, 1 over 1, 1. After all that, the answer is 1. Did you track with that? So we find where we're at on the circle, and then you take the coordinates. It's backwards. Cosine comes first, then sine, by definition. And then you can find the value. The cosine of 0 is 1, 1 over 1, 1. You remember all that? Is that what you learned in trig? All right, good. But the sine of 60 plus the cosine of 45. So let's go to the unit circle and find where we end up. So here we go. Okay, so let's start with 60. So remember what we learned a little bit last time? Where these angles are? So where is 60 degrees? It's right about there, huh? It's almost to 90, isn't it?
Pi over 3, not pi over 6.
So now, what you do is you locate where you're at in the circle. Sine of 60, it's right there. And then you think about how far from the origin, how far over and how far up to get to that point. How far over, how far up? It's over a small amount. Remember the 3 numbers we use? Square root of 1, square root of 2, square root of 3, all over 2. And square root of 1, you don't need the root. Square root of 1 is just 1, huh? So it's 1, 2, 3, square root of 1, 2. Remember that's small, medium, large. So we go over a small amount, up a large amount, don't we? Over just a little bit from the origin, up a lot. So this is the point, over half, up root 3 over 2. They defined the x. The first one is always cosine. The second one is always sine. They just made it that way for its practical uses. So therefore, what do we want? Sine 60? Root 3 over 2. So we got that. Plus, now let's do the cosine of 45. So 45 is right in the middle, isn't it? 45 is right there. Yeah, and the ones in the middle are medium, because they're right in the middle. They're not over large or small. They're over medium, which is root 2 over 2, right, the medium one. The medium one always goes with himself. He doesn't ever mix with the small or large. So over medium, up medium. So this is the point, root 2 over 2, root 2 over 2. That's how the middle ones all the way around the circle always are. They always just have the root 2's over 2. They always have the mediums. All the other ones mix the small with the large. So what do they want? Cosine. It's always cosine first, sine seconds, reverse. They defined it that way. Cosine is root 2 over 2. Add those together. I don't know if you remember, you can't add roots. They just stay separate like that. But common denominator, you can make it one fraction. There it is. That's how they want it. They don't want decimals. Good. You remember all that? That all coming back? All right. I'll keep moving if you're good. Questions? Okay, so there's our question.
Is it pi over 360 degrees?
Yes.
Okay, so I'm not going to need to convert it all because it's already on there. So secant, what do we always do for secant?
Switching.
It's r over x.
1 over cosine. I'll just go back to that wherever it is. I don't remember. There it is. Secant is 1 over cosine. And cotan is cosine over sine.
So X
So this will be cosine
Mm-hmm.
over sine. We good to there so far? So I just changed everything's to sines and cosines, notice. All of trig is really sines and cosines. Keep going. Now, how do I get cosine of pi over 6? Go to the unit circle.
Pi over 6 is 30 degrees.
It's right here. You don't even need to convert. That's what's nice about this unit circle. The radians are right on there for you. But yeah, you're right. Pi over 6, because pi is 180. 180 divided by 6, same as 30. Remember how to convert? I mean, you don't have to. They're already there for you. But it might be helpful. Pi is 180.
It's root 3 over 2.
Remember that? Like on the back here. I think we had it back somewhere. Well, whatever.
I'm trying to access the ring.
Right here. Yeah, this is 0 degrees. This is 180. 180 is pi. Because all the way around is 2 pi. So pi is halfway. Pi is 180. So whenever you see pi, you can just replace it with 180 if you want to change to degrees. Pi is 180. Halfway around. They're both halfway, because 2 pi is all the way around. So pi is halfway. 180. So anyway, yeah, so this is, so that's why pi over 6 is 180 over 6. 18 divided by 6 is 3. That's 30 degrees. Anyway, we don't care. It's already there for us. 30 degrees, pi over 6. Cosine, sine. Remember, it's reverse order. Cosine, sine. What do I want? Cosine, right? Root 3 over 2. So cosine of pi over 6, root 3 over 2. Let's go back. Root 3 over 2 plus 7. Now I want cosine of pi over 3. Let's go get cosine of pi over 3. So here's pi over 3. Cosine, sine. Cosine's a half. Sine's root 3 over 2. Cosine's a half. Sine's root 3 over 2. See how I'm getting those right off the unit circle? No calculator needed. That's what you'll be able to do next Thursday. Okay. So now how do we clean this up? You know, fractions in the bottom of a fraction. We've got to grab that thing and flip it up. So it's 5 times, I'm going to kind of, so it gets a little messy here. 5 times 2 over root 3. Good so far? And that's 5 over 1, huh? So multiply top with top, bottom with bottom. That's 10 over root 3. And we never leave roots in the bottom. So you multiply top and bottom by root 3 to rationalize it. That's 10 root 3 over plane 3. We good to there? Plus, and then the other one, you grab that root 3 over 2 in the bottom and flip it up. It's going to be 7 times a half times 2 over root 3. These cancel. So it's 7 over root 3. Never leave a root on the bottom. So it's plus 7 root 3 over plane 3, which is 17 root 3 over plane 3. Done.
Some of them, they're going to come out even numbers, and then they want you to reduce them before you enter your answer. Like, for instance, if it was 2 root 3 over 12, or like 24.
Yeah, always got to reduce. Yeah, like any fraction. Good to there? Is that making sense on that? Questions I can answer? Is that all good? Everybody tracking with all those steps? So I just changed secant to 1 over cosine, cotan to cosine over sine, went to the unit circle, got the values, flipped them up, got rid of the roots from the bottom, added them together. No questions? All is good? They give me 17 pi over 4. They want me to find all 6 trig functions, sine, cosine, tangent, and the other 3, from 17 pi over 4. Now, 17 pi over 4, what should we do with 7? If you go to the unit circle, you know, you're not going to see 17 pi over 4.
But it's in increments of 45 degrees.
There's no 17 pi over 4. Yeah, so what should we do with 17 pi over 4? Do you realize that that's more than 2 pi? Right, because 4 goes into 17 like more than 4 times. So that's more than 2 pi, isn't it? Right? 8 pi over 4 would be 2 pi, wouldn't it? So that's more than 2 pi. What's my point? Well, that's more than a full rotation. So we should subtract out the extra rotations. Do you know what I mean? Subtract 2 pi, however many times you can, because they're giving me, they'd be like me saying 1,000 degrees. Well, what's 1,000 degrees? I don't know. It's 360. You know, take out the 360s, find where it ends up on the circle. So let's do that. So this is going to be 17 pi over 4 minus. Now, how do we subtract 2 pi? This is all no calculator, right? This will be on the part 1, no calculator.
What I would do is I would see how many times 4 goes into 17 and see what's left.
You could do that. I'm going to just do it this way this time. I'd put a 1 under, multiply top and bottom by 4, right? 8 pi over 4, that's 2 pi, right? If you subtract those, what do you get? Isn't it 9 pi over 4? Is that good to there? And now, what should I do with 9 pi over 4? Subtract another 8 pi over 4, which leaves you with just 1 pi over 4, or pi over 4. Is that good? Everybody see? And then I go to the unit circle for pi over 4, find all my trig functions. So find the sine of pi over 4, cosine of pi over 4, tangent of pi over 4. Am I going too fast? Is this making sense? So if they give you a big old whopping angle that's more than 2 pi, just subtract out some 2 pi's until you get it under 2 pi. Just subtract as many 2 pi's out as you can. That making sense? So when they gave me the original angle 17 pi over 4, what they were saying is they were saying go around a bunch of times and then finally end up at pi over 4. Does that make sense? Those extra rotations don't do anything, do they? Right? So if I drew the circle, what that really means, 17 pi over 4 means start at 0, we always start at 0, do a full 2 pi, do another 2 pi, and then do pi over 4. So you might as well just do pi over 4. It's the same ending spot. They call that coterminal. It ends with it. Co-terminal, terminal ending. So ending in the same spot, coterminal.
It's just 1.
Is that making sense? Are we good so far? So I subtract out those extra rotations. They do nothing. The extra 2 pi, then pi over 4. So now I just go to the unit circle looking for pi over 4. Here's pi over 4. Cosine, sine. They're both root 2 over 2, aren't they? So go back. Okay, sine is root 2 over 2. Cosine is root 2 over 2. Tangent is sine over cosine, which is 1. And then for the other 3, flip it. Get rid of the roots from the bottom. Yep.
And also we should take care of what the side too, because since we are the first one, they're all like, it's going to be positive. If you're going to the second one, so it sounds.
Yeah, we'll get to the signs in a little bit. Yeah, for now these are all positive. We good there? That makes sense?
Multiply like those 17 pi, so you can multiply 17 times 180 divided by 4, and then subtract 360.
You could. That might be harder to do by hand with no calculator. That's why I showed this way. But you're totally right, Jose. Yeah, you could just put in a 180, because that's what pi is, and then times 17 divided by 4, and then you get some big old angle. Yeah, and then, yeah, what is it? It's 360 and 45. It's going to be 405 degrees. No, at 360. 770, I think. Because it's 360 twice, 720, and 45. 765. Yeah, 765. So you get 765 degrees. Then you'd have to subtract 360, and you'd get, no, not 45. 45 degrees. And then you can go to the unit circle. Yeah, that'll work too, if that's easier for you. Yeah. That makes sense, what Jose was saying? Just put in a 180 there. You could do that. Yep, if you'd prefer to work in degrees, which is sometimes easier, even when the numbers are big. They want me to find all 6 trig functions from negative 210 degrees. So here's 0. So where's negative 210 degrees?
You go down.
You go down, huh? So if you start here, you go down. So negative angles go down, positive angles go up, negative angles go down. You start at 0, go up for positive, down for negative. So you're going to go down to 10. Where's that going to be?
Right. So 180.
It's about right there, huh?
180 plus 30. So
Yeah. It's
your
going in
reference
this.
angle is going to be 30 degrees.
Right. So the easy way to find it, we can see it there. I just wanted to physically show you that. I would just add 360. And you'll get, what's that, positive 150 degrees, which is
This first
that spot, huh? It's almost to 180.
Because that's what
So positive 150 is the same as negative 210. Does everybody see that? So then you just go to the unit circle for 150 degrees. Just go, okay. Once you get your angle, it's cake, right? Just go to the unit circle, go 150 right there, cosine sine, you can get cosine sine and all the rest. We good? With that?
Yeah.
All right. Got it with you. How are we going to do secant? We don't have a secant button.
1 over cosine.
Yeah, remember he's 1 over cosine. Okay, so can you take your calculator real quick? Make sure you're in degree mode. Do you know how to do the mode? Mode button's at the top. Mode's at the top if you have the TI anyway. Mode button's up there at the top. Hit mode. Make sure you're in degree. I'm in radian right now. Degree. And then hit 1 divided by cosine 77. I'm getting 4.445. And they say round to the second decimal, so look 1 to the right, makes me round up 4.45. You able to get that okay?
Okay. And we have to put some radians.
Oh, yeah, no.
And number 15, they're asking cotan of 2 pi over 13. Yeah. Cotan of 2 pi over 13. What's cotan?
The inverse of tangent. So it's
Whatever
x
tangent.
over y.
So it's cosine
Percent.
over sine.
19.54.
So sines and cosines. So I think it's easy just to break everything into cosines and sines. So like that. Now, is that a radian angle?
Yes.
Yeah. How do you know it's a radian angle? Make sure your calculator's in radian mode,
Yeah.
Renee. How do you know it's radians and not degrees?
Because there's
Yeah, it's not actually the pi. Watch out. That'll fool you if you're relying upon the pi. It's because they don't have a degree symbol. In other words, if they asked me secant of 77 and didn't put a degree symbol, then that would be radians. It doesn't have to have a pi, in other words. It's just whether it has the degree symbol or not. That's the indicator. It doesn't have to have a pi. They almost always do for radians, so we can get kind of fooled by that. So watch out. Don't let them fool you. If it has the degree symbol, it's degrees. If it doesn't, it's automatically radians, even if it doesn't have a pi. So this one's radians. So do cosine of 2 pi over 30. Use the pi button.
Yeah.
The pi button is right above the up arrow, the power button on the right side. The up arrow. Hit second and the up arrow, and you get the pi button. So I'm going to do cosine of 2 pi over 13 divided by sine of 2 pi over 13. I'm getting 118.54. Y'all able to get that?
So when you look at it now, I can see.
You put it in degrees, right? Is that in degrees?
Oh, maybe I messed up.
Because I got 1.90.
Yeah. I think
Oh,
Yeah.
just kidding.
That's what I got for degrees. You know.
I was trying to show you how bad Renee did it.
You gotta put it in radians.
Shamefully
Mr. Harry.
bad. So bad.
Yeah, because I messed up and I was like, oh, I gotta put it in radians.
He was just copying you.
I know, right? Makes sense.
Right. You're leading me astray.
There were strong words.
So, here's the real answer. 1.905. So they want you to round to 2 places. 1.91. That's better.
I was like, that's kind of big.
Are we good? So make sure you're in the right mode. Questions I can answer? All right, I'm going to move on.
Double angle identities.
Oh, those are horrible lessons.
Yeah, we're not going to do those. So is everybody good? Any questions I can answer?
I don't know.
I think this is some difference.
Okay, so they're giving me a point now, an x and a y, and they want me to find sine, cosine, tangent, all 6 trig functions. The trick on this one,
Is to find R.
yeah, so you might think, well, sine is just the y-coordinate, so it's just 3, done. But there's one mistake with that. Remember the original definition of sine, it's actually y over r. Now, we can just say y if r is 1. When is r 1?
When you're on the unit.
When you're on the unit circle. This one's not on the unit circle. How do I know? Well, think about that point. Back 8, 3, 4, 5, 6, 7, 8. Let me just actually do this dot. Here's the back 8, up 3. So it's right there. There's back 8, up 3. If you go back 8 and up 3, back 8 and up 3, how and you put that on a circle. I made a big circle here. Let me do that. Well, mine's not a very good circle, but whatever. Yeah, the radius of that circle will not be 1. From the middle to the edge, the radius. How could I find the radius there?
You can use Pythagorean theorem.
The Pythagorean theorems. Everybody see that? Right? Because it's back 8, up 3. X and Y coordinates make right angles with each other, don't they? Because they're perfectly sideways, perfectly up and down. So back 8, up 3 makes a right triangle. Whenever you have a right triangle, you can use the Pythagorean theorem. A squared plus b squared is c squared. When you're using the Pythagorean theorem, you just got to be careful to make sure you get the c correct. The a and the b order doesn't matter, but the c does. Which one is the c?
It's the R.
It's the r.
The hypotenuse. Yeah, but
So 3 squared plus negative 8 squared is the r squared.
Right across from the
9 plus 64 is r squared. 73, root it, there it is.
73.
So it's 3 over root 73.
Ew.
So the sine is not just 3. Remember, the sine is y over r. Only if the r is 1. Only if we're on the unit circle. This is not the unit circle.
3 root 73 over 73.
Yeah, so then you can't leave the root in the bottom, as you know. So you multiply top and bottom by root 73. And you get 3 root 73 over 73. And then you could do the rest, right? Cosine, well, let me do one more. Cosine would be x over r.
8 root 73.
So it would be x, what was x? Negative 8. Negative 8 over root 73. And again, multiply top and bottom by root 73.
And tangent would just be 3, negative 3 eighths.
yes.
Yes. So we good with that?
I think cotangent would be next.
Am I rushing you on through? Is this okay?
Yes. These are fun. I actually like these.
These are way better than the other trick I did.
I actually like
Like the second half of the semester. Let's try that.
Is that making sense? I see how I found the radius there? So I just went back 8, up 3. So that's a right triangle. Found the radius with the Pythag. And remember, sine is y over r. Cosine is x over r. Normally, r is just 1 on the unit circle. So we don't have to do this. But they're specifically give me a point not in the unit circle. That's rare. Like, I probably won't even put one of these on the test. I don't exactly remember. There might be one, but probably not. I mean, this is totally rare. Normally, you're on the unit circle. Radius 1.
And make the whole test just this.
Just these, huh?
yeah.
All right, good there. So okay, so there's the question. So f of x is sine x, h of x is 2x, and they want f of h of pi over 6.
What?
Yeah, so what's that little circle floaty thing in the middle between the f and the h there? This little guy, remember that?
Yeah. You have to substitute.
Yeah, it's plugging. Remember, it's plugging the right into the left like that. Remember, functions always plug in right to left, don't they?
Yeah.
Like whenever you say, what's f of 2? You mean 2 into f, huh? Functions are always right to left. So when they put two of them together with the little O thing, that means composition, that means compose them. Like a musical composition puts all the instruments together into one piece of music, right? That's what we're doing with the functions, plugging them into each other. So that means we got to take f of h
Pi over 3.
of pi over 6 like that.
So,
That would be 6.
Does that make sense?
no.
So let's start with the inside.
Pi over
Yeah,
3
that's right. Because there's not.
So just the inside. What's h
times 2 pi over 3.
of pi over 6?
Yeah.
H of pi over 6. Start with the inside.
I did that all by memory.
I do that all in my head.
Yeah.
So how do we do h of pi over 6? Here's the h function. It's 2 times whatever you plug into it, huh?
Pi over 6. Yeah.
Is that making sense? That's what he says. He says, I'm the h function. Anything you plug in goes right there, multiplied next to it 2.
2 pi over 6, which reduces
So how do you do a whole number times a fraction?
pi over 1.
Over 1, cross cancel, pi over 3. So the inside, this, has become pi over 3. Good to there. So now put pi over 3 into the f of x function. And so you get sine of pi over 3.
Root 3 of 3.
Then you just go to the unit circle. Pi over 3, cosine sine, root 3 over 2.
Oh, root 3 over 7. That was
I
right.
said root 3.
Yeah, 3. That's what I said.
How we doing? Anything I can help with there?
So
I did this part
the
separately.
first trig functions go 1, 2, 3 over 2, root, root, root. The second set of trig functions go 3, 2, 1, root, root, root over 2, 2, 2. Right?
I don't know. Check with me later.
Yeah, I'm pretty sure.
All right, we good on that? I'm going to move on. We okay?
I don't understand what you just said.
Over 3. So they want f of pi over 3. So they're just simply calling sine of x by the name f of x. And they want me to plug in pi over 3. So they want the sine of pi over 3, don't they? F of x is just the sine. So sine of pi over 3, go to the unit circle. Oops. Oops. That's not what I meant to do. So pi over 3. Cosine sine. Sine is root 3 over 2. Good so far? Now, part B says, using the result, what is the point on the graph? Oh, no, I'm sorry. We didn't finish A. What point? So let me show you what they, where am I? Okay, now, they're saying what point on the graph is that? Well, a point is an x comma y. So they want two numbers with a comma. When they're asking for a point, now how do you know what's the x, what's the y? X is always what you plug in. Y is the answer you get out. So pi over 3, comma root 3 over 2. Does that make sense what they're wanting from you on that? Whenever you deal with a function, what you plug into the inside is your x. What comes out of it is your y. Like that. Is that good? So this is x, what we plug in. What comes out, the answer is y. So then on the next one, they're going to say, what's the point on f inverse? Now they're going to bring back inverse functions. Remember those?
No.
Yes, you do. Yes, you do.
So what happened? What does an inverse function do? It inverts something.
Things.
It inverts x and y, remember? So you're just going to trade these two. So it's just going to be root 3 over 2, comma pi over 3, done. X and Y just trade. They just want to make sure you remember what inverse functions do. They invert X and Y. Remember, that's how we found them. We would switch X and Y, solve for Y. You guys haven't forgotten anything we've done in this class, right? For all 18 weeks. These are long semesters. It's hard to keep it all together. Is that good? So that's all they want. So they're just saying, hey, plug into this function, get an answer, make it a point. It's kind of weird to make it a point, you know. So you do the x, y, what you plug in is x, what comes out is y. Then they go, what's the point on the inverse? You just swap them. And then, okay, so we're shooting some projectile at some angle theta, blah, 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 blah. So what's R?
Range.
Range. The range, let me change the color here. The range and the maximum height of the projectile. Oh yeah, range is how far you shoot it. That's R. And H is your height, the maximum height. So there's a formula, It's from physics. Find the range if the projectile is at 65. So here, you don't need all those words. So basically they're just saying, here's an R function, a V naught squared sine 2 theta over G. So they give me that function, saying find R, 65. So part A says, find R when theta is 65. So it's just a function. Just plug in 65. So let's go, okay. R of 65 degrees is V naught squared. Now what's V naught? They probably told me that somewhere. Oh, right here. Initial speed 240, that's V naught. So they're telling me V naught is 240. Remember, whenever you have sub-zero in a science formula, this is physics here, what does it mean? Have we talked about that? I think we have.
Zero.
At time zero. That means velocity at time zero, initial velocity. So that's really important if you're going to take physics. They do a lot of initial velocity, later velocity, that kind of thing. So anyway, initial velocity squared, so that'd be 240 squared times the sine of 2 times theta, 2 times 65 degrees, over G. What's G?
Gravity?
Gravity. Do you know what gravity is? What's the acceleration due to gravity?
No.
Anybody in physics has done it 10 billion times. It's 9.8. Here it is. 9.8 meters per second. 9.8. Hit the buttons on your calculator. Oh, this angle, this will become, what, 240 squared. Here, let me change the color there. Make it easier to see. So this will be 240 squared sine 2 times 65. Isn't that like 130? Over 9.8. Hit the buttons. Whoops, don't break your calculator. 240 squared times sine 130 divided by 9.8 is, I got negative.
Oh. How?
Yeah, that's crazy.
It's not a radian, right?
It is a million.
Oh, yeah. Good thing you're here to correct me. I just love to be corrected. Sine of 130.
No, it's not actually us correcting you, it's Alvin's teaching.
Yes, only Joel filled that in. He's like, did you check your calculator?
Yeah, you should bring that up to him.
Literally. Second, I'm going to tell him this like next semester.
Yeah.
Like, so you're teaching, help me out.
4502. I'll send him an email that I didn't check my calculator. 4502.46. That's better. Positive distance is always better than negative.
So G is going to be 9.8.
Yeah. Right. Yeah, they tell you that right in the problem. Yeah, well, I should have written it. G is 9.8. You done some of that, Abdul? You done some physics?
Yeah, I guess.
I can hear.
A long time ago, yeah.
Yeah, I don't even get to start physics till
I haven't taken it yet.
You're done.
I have to start my second semester of calculus.
Yeah, Calc 2 has to be concurrent.
Yeah.
Yeah. 4502.46, we good?